Today we are doing Eureka Math Module 3, Lesson 9, and it's going to add on to everything we've learned so far in Module 3, and hopefully it'll help to clarify some confusion that you might have about adding and subtracting fractions. Okay? Today our learning goal says I can use what I know about making equivalent fractions to help me add fractions. In order to understand our learning goal, we need to know what those different parts mean. What does it mean if something is equivalent? Equivalent is just a fancy math word to mean the equal or same, right? So if two fractions are equivalent, that means that they are equal or they're worth the same amount. The word equivalent could apply to lots of things, not just fractions. If I have 4 quarters, if I give Priya 4 quarters and I give Niv $1 bill, did I give them equivalent amounts of money? Yeah. If I give Rahi 5 pennies, what could I give Prisha that would be equivalent? Everyone? 1 nickel. If I give Arnav 1/2, what could I give Luke that would be equivalent? 2/4. What else could I give Luke that would be equivalent? 3/6. Is there a certain number of equivalent fractions you can make? No, it's kind of like what we were talking about yesterday with the number 1 and the Pokemon Ditto, remember? What's one version of 1? What's something that's equivalent to 1? Rishit? 7/7 is equivalent to 1. What else is equivalent to 1? Maddie?
15/15.
15/15. Very good. Samarth, what else is equivalent to 1? 1/1. Absolutely. So today we're going to think a lot about equivalent fractions, things that are equal to each other, and use that to help us add fractions. The fraction 5/4 is what we call an improper fraction. And I actually do want you to write this part down. Proper fraction. Whenever we have improper fractions, that means it is not in its simplest form. How do we know it's an improper fraction? Well, the numerator is what number? 5. And the denominator is what number? So which one's bigger, the numerator or the denominator? Whenever the numerator is bigger than the denominator, we know that that is an improper fraction. What it means is that it actually has a hole in it. Do you guys agree that 5/4 is the same thing as 4/4 plus 1/4? Yeah? 4/4 is really what number in disguise? So this is the same as 1 and 1/4. And now it is in its simplest form. Okay? So you always will know a fraction is not simplified if it's an improper fraction or if the numerator and denominator are divisible by the same number. Are 1 and 4 divisible by the same number? Well, they're both divisible by 1. But other than that, no, right? So that means it's in its simplest form. If we want to add two fractions that do not have the same units, 1/2 and 1/5, for instance, we need to rewrite the problem using equivalent fractions that have like units. Like units just mean that they have the same denominator. If something is in common, it means it's the same, right? So we need to change them so that they have common units, like units, okay? Today, what I want you to do is I want you to copy out these 3 steps, and we're going to do the 3 steps together. But in your notebook, I want you to write step 1, and then write out what it says right there. Take some time to write it down right now. Step 1 says you need to find the LCD. LCD is a shorthand. It means least common denominator. Let's take out what those words mean one by one. If something is the least, is it the biggest or smallest? Okay. If something is in common, what does that mean? The same. And denominator we know is the bottom number of the fraction. Okay. And we're going to do that by finding the LCM. Oh my gosh, another abbreviation. Again, L stands for least, which means what? Smallest. Common, which means the same. And multiple. We're going to find the multiples of these numbers. This should be a review from 4th grade. Yes? Good. So what we're going to do is we're going to take each of the denominators. The first denominator is 2. And we are going to write out the multiples of that number. In other words, we're going to skip count by 2. You can see I put a 2 here, and I put a colon to show that now I'm going to skip count by 2. So here we go. 2, 4, 6, 8, 10, 12, etc. Okay? Very good. My second denominator is what number? 5. So now we're going to try to write out the multiples of 5. Here we go. 5, 10, 15. I can stop now. I can stop because do I have a number in common, a multiple in common? What's the multiple I have in common? 10. This is the smallest number I'll have in common. Is it the only number I'll have in common? No, I might have 30 in common or 50, right? But I want the least one, okay? So 10. That means that 10 is what I want to be my least common denominator. I want to rewrite these fractions now, 1/2 and 1/5, so that they have the denominator of 10. Okay. I want to write equivalent fractions, a different version of 1/2 that's over 10 instead. Okay, so you have to think to yourself, how did I get from 2 to 10? What did I have to do? I multiplied by 5. Can I just multiply by 5? Well, if I multiply a number by 5, will it change its value? Will it? Yeah. I need to multiply the number by what? There's only one number in the entire world that you can always multiply by and it will not change the value. What's that number? Everyone show me with your fingers. 1. Very good. So if I know I need to multiply by something over 5, what version of 1 should I use? Everyone? 5 over 5. Okay. Now, if I multiply 1/2 by 5 over 5, I can multiply the numerators. 1 times 5 is 5, and 2 times 5 is 10. That means that 5 over 10 has the same value or is equivalent to 1/2. Let's try that with 1/5. We also want the denominator to become 10. What do I have to multiply 5 by to get to 10? Everyone? 2. So what version of 1 should we multiply this fraction by? 2 over 2. So 1/5 is equivalent to how many tenths? 2 tenths. Very good. So now we know that 1/5 is equivalent to 2 tenths. They have the same value. If I give Samarth 1/5 and I give Geffen 2 tenths, is that fair? They have the same amount, right? If I give Jayanth 1/2, how many tenths would I have to give Aradhana to give them the same amount? No, I'm giving Jayanth 1/2. I want to give Aradhana some number of tenths. How many tenths? 5 tenths. Very good. So then now we know what the equivalent fractions are with the LCD, with the least common denominator. So step 3, you just rewrite the problem, right? And you use those equivalent fractions. So instead of 1/2, what should we write? 5 tenths. Instead of 1/5, how many tenths should we write? 2 tenths. And now do we have like units?
Yeah.
Now we're ready to add. If I have 5 tenths, and I add 2 more tenths, how many tenths do I have? 7 tenths. And then at the very end, we always have to check, before I box my answer, is it in simplest form? Are 7 and 10 divisible by the same number? No. So that we can box our answer. We know now that 1/2 plus 1/5 is equal to 7 tenths. If we want to add 1/2 plus 2/3, are we ready to add right off the bat? Do we have the same units? What kind of units do we have in the first number, 1/2? We have? No, we don't have 2's. We have halves. Very good. What about in the second one, 2/3? What are our units there? Thirds. Are halves and thirds the same thing? No, they're different. So we got to make them the same. So our first step, we have to write out all the multiples to find our least common multiple, which will then be our least common denominator. So our first denominator is 2. Let's skip count by 2. Ready? Go. 2, 4, 6, 8, 10, etc. Okay, very good. What's our second denominator? 3. That means we have to write out the skip counting by 3's. Ready? Go. 3, 6. Oh, can we stop? We know we can stop because we have something in common. What is our least common multiple? 6. Very good. That means we want to now move on to step 2. We want to rewrite each fraction using an equivalent fraction with the LCD. So our first fraction was 1/2. And we know we're going to need to multiply that by some version of 1 in order to get an equivalent fraction where the denominator is what number? We want our new denominator to be 6. Very good. So think to yourself, how do I get from a denominator of 2 to a denominator of 6? I have to multiply by. So what version of 1 shall we multiply 1/2 by? 3 over 3. That tells us that 1/2 is equivalent to 3/6 because in the numerators, 1 times 3 equals 3 and 2 times 3 equals 6. Okay, very good. Let's do the same thing with our second fraction. We have 2/3. We're going to have to multiply that by some version of 1 in order to get some fraction where the denominator is 6. Very good. Okay, think to yourself, if I started with the 3 and I want to end up with the 6, what number did I have to multiply by? 2, which means we want to multiply 2/3 by what version of 1? 2 over 2. Very good. That tells us that 2/3 is equivalent to 4/6. Okay, now I have to rewrite my original problem, and this is a chance for you to make silly mistakes. Oftentimes, people will write the wrong problem down after they're done finding the equivalent fractions. What should our new problem be that we want to write down? Akil? 3/6 plus. Very nice. And now do we have like units? Yes, both terms are in sixths. So if I have 3/6 and I add 4 more, how many 6 do I have? 7/6. Now we have to think to ourselves before we box the answer. Is this in simplest form? How do you know it's not in simplest form? Aradhana? It's not very proper, is it? There's more on the top than there is on the bottom. That tells us there's at least one hole. How many 6 does it take to make one hole? 6. And how many 6 do I have?
7.
So would you agree that 7/6 is the same thing as 6/6 plus 1/6? Which means it's the same thing as 1 plus 1/6? There we go. And now it's in simplest form.